What happens when a breakthrough in semiconductor design makes satellite positioning smaller, smarter, cheaper, and dramatically more power efficient? Welcome to Industry Ignited. I'm Dr. Leanne Aguilar, and today I'm joined by Tom Trill, CEO of Qualynx, a Delft University spinoff redefining GNSS technology through scalable digital RF semiconductor innovation. Tom, welcome to the show.
Thanks, Leanne.
Well, Tom, you've built a career across global semiconductor leaders, startups, and emerging technologies. Looking back, what experiences most shaped the way you lead today?
That's a great question. It's quite insightful. I think the evolution of how I've grown from being a manager to a leader. I think the crystallization of a lot of the learning that you synthesize from being managed to becoming a manager, and the ability to carry that forth into a leadership role has shaped me and formed me quite a lot. And to be a little bit more specific, I used to feel as a manager that it was my job to help the team deliver results, keep them in their lane and their functional deliverables. And then the evolution of that thought was, no, we need to shapeshift around the core competencies of the team to get the most out of them, and for that to be a win-win so that the team members are happy, satisfied, fulfilled, and challenged. And that was the first sort of breakthrough for me. And then you begin to realize then that delegation was much, much more than just handing off stuff and managing people, into giving autonomy to people. And there's all elements of trust underneath that, and so on and so forth. And that in and of itself is quite fascinating. The three different types of trust, you kind of, as you become a leader, then you move from the real Lagos type trust to the pathos and the ethos as well. And I think that really summarizes the evolution of how we look at leading people.
That's interesting. Yeah, I like how you described the delegation. Your concept of delegation changed as well. I remember like the best boss I ever had told me once that great managers, they delegate. They delegate everything. So tell me a little bit more about what delegation looks like with a manager versus a leader, like how that evolved for you.
Yeah, through my own lens, it seems like a rising star who's given a management role. And I was fortunate enough to have been given management roles. You're full of enthusiasm and you want to mentor as much and coach as much as you can, but that translates into a very to-do list. As I grew through that, I realized that, oh, that's not effective. I wouldn't like that myself. I don't respond well to that type of oversight, if you like, or management. And you just begin to recognize people's core competencies, where their comfort zones are, and why push them out of their natural comfort zone. You know, there's, in my opinion, there's only one major reason to do that, is if you see potential, or if the person asks for growth and training. Then sure, facilitate it, absolutely, and help that person grow through. I think that's a virtuous cycle right there. And that just evolved into our philosophy now at Qualynx is we're a deep tech company, and not only are we deep tech, but we're pioneers in the field of RF technology that's called digital RF. And it's not taught in schools. When the best engineers that we have join our company, we have to spend another 1 to 2 quarters training them and bringing them up to speed and educating them on our approach. So it's super complicated. But despite that, our first principle when it comes to hiring is cultural fit. And you can help and train anybody in any role so long as they have foundational competency and knowledge. But it's much, much harder to drive a cultural change, even in an individual. So that's what we hire for. And I think that philosophy is born out of just the years of experience.
So you're telling me about how when you hire, you really look for fit. You really look for cultural fit and not just the skill set, because especially it makes sense, like in an emerging field, often there's not schooling or training that you can really get for your type of technology. And so it makes sense that you would hire for fit. Tell me, I guess, a little bit more about that.
Yeah, that's our first principles when it comes to hiring is cultural fit. And we know that if there is a fundamental competency and talent or education and engineering, that we have the wherewithal from our founders through to our more tenured employees to train and bring the new engineers up to speed on our fundamental technology. So you can train for that, but it's incredibly difficult to train for cultural change. And in our company, we're now coming up on about 60 employees in our headquarters in Delft, in the Netherlands, with a couple of remote offices also. But in Delft, over 50% of the employees relocated internationally to join us.
Oh, wow.
Um, yeah, and the geographical diversity is super impressive. We have employees from all over the world, from Japan, the Philippines, from India, from Egypt, all the European countries, and from the United States, Latin America. Very, very diverse. And the thing that we're most proud of is a lot of those employees have never left their home country. They have had early career starts in their home countries, but yet they had the trust and the aspiration to relocate into the Netherlands and join our company. And I think that's a badge of honor for us and for our team.
Yeah, that is impressive. So, right, looking for
Mhm.
people who are open to that change and growth and curious about other cultures and
Mm,
willing to work with that diversity. That's
yeah.
awesome.
It tells you something about their character and their personality as well, that they're, no matter what the functional competency is or what the job is that they're applying for, the common bond is an entrepreneurial spirit, fire in the belly that, gives someone the confidence to just give it a go, give it a shot.
Yeah.
Yeah. And I think that's the common bond.
Now, you started in Europe, built much of your career in the US, and then returned to help scale a deep tech company in Europe. How did that international journey shape your perspective on innovation and execution?
Yeah, the semiconductor industry, nowadays we talk about how globalized it is versus the need for sovereignty in deep tech. But it is truly a global industry. And it doesn't matter where you are in the world. If you're in the industry, the world is very flat. And well, for the record, I know it's not, but it's just in our space, it is when it comes to semiconductors and the intricacies in the ecosystem give anybody anywhere in the world platform to experience the norms and the values and the modus operandi of their peers from the opposite corners of the globe. And there's almost a homogeneity once you switch on your semiconductor hat that unifies everybody, no matter where you're from. I find that to be really interesting and really fascinating.
Yeah, probably because it is such a small space, because it's a small
Mhm.
world, there's more connectivity.
Yeah.
Now, before joining Qualynx, you had already seen key industry pain points around connectivity, scaling, and
Mhm.
RF limitations. What was it about Qualynx that immediately told you this was different?
Back in 2010 and 2011, I was working with a company who had made a couple of acquisitions, and we were trying to build a IoT edge node. And we had all of the components, sensors, harvester, logic, memory, but we had no connectivity. And I spent maybe the best part of a year sourcing IP for connectivity, and we couldn't find anything that was affordable. And we defined affordability in terms of power, size, and performance and cost. It's not just the price per se, it's how much power is it consuming, and nothing was efficient enough for us to build an edge node. So we shelved the project. And then 9 years later, I meet the founders of Qualynx, who had invented the technology, our novelty per se. I said to myself, if I had had that back in 2011, we'd have been enabling the edge a lot more efficiently than it is right now. So it was a no-brainer for me in terms of the technology and the demand side. And when we looked at the business, we said, well, if it's funded, this is about execution. It's not
Mm-hmm.
about invention. It's not about R&D. It's about execution. We've been very fortunate to have raised an A series back in 2022, and we set about to execute. And here we are. We're about to launch into mass production now. So, yeah, quite successful so far.
Right. So tell me more about what great execution looks like in a company like this.
Mm. Oh, no, that's a good question. I think there are two analogies, and one of them is a bit tongue in cheek, but some teachers in the first early years of their careers say that you're good so long as you stay one chapter ahead of the class. So you always know what's coming next. And then the other metaphor analogy is that you lay the road in front of you just before you take that step onto the next. You're laying the bricks ahead of you, and that's very much how we've scaled the company in terms of execution. We've operationalized, invested in, and hired the people for the functional areas just as we needed them. Whether that was HR in the early days. When we started off, there were four of us in mid and early 2022, and we're running the company. So one of our co-founders was managing HR and finance and purchasing. Now he doesn't know how to spell HR. He's that far away from it.
Right.
And that's what you do. It's a rising tide. And as the company evolves, you've just got to resource those operational and functional needs at the right time.
Right.
It sounds fairly, simple, and it is simple, but it's not easy.
Yeah, but I think it comes down to timing and really feeling out what's coming ahead, like you were saying, just
Yeah.
keeping the eye on the ball, looking at what's on the horizon and being able to move quickly. And I guess when you're small, there's a lot of agility, you can move pretty quickly. As you grow, then it's harder to move as fast. But
Yeah.
yeah.
I think the recipe is that agility, maintaining that agility, but also just having the experience to know what's coming next, and not to be afraid and to resource prematurely, because then you've not really been deploying the capital efficiently if you do that.
Yeah.
But also not doing it too late, because if you do, the risks are huge.
Right, right. So balancing that risk and
Yeah,
timing comes down to timing,
yeah,
like you're mentioning.
yeah.
So for listeners who may not live in the semiconductor world every day, what exactly is Qualing's building, and why is digital RF such a meaningful leap forward in GNSS?
Yeah, there are two interesting components to the answer to that question. Firstly, we build what's called a GNSS receiver chip. GNSS means the Global Navigation Satellite System, more commonly known as GPS or navigation sat nav or so on and so forth. Globally, each major geographical area has their own constellation of satellites that are used for positioning, navigation, and timing here on the planet. In the US was a pioneer with GPS, and in Europe, the constellation is called Galileo, with 34 satellites providing global connectivity alongside GPS. There's one from China, from Russia, from India, and Japan. So 6 constellations combined to give about a couple of hundred satellites in all. So we design a semiconductor chip that can receive your location data and timing data from these satellite constellations. That then is translated into your common apps for navigation, positioning, and so on and so forth. Our technology is also capable of receiving signals from land-based IoT radios, long range or short range. Things like, you'll be familiar with BLE or Bluetooth or Wi-Fi, and then some of the more industrial implementations of IoT radios like LoRaWAN or NB-IoT, or some of the types of protocols that we're talking about. So that's what we build. The end applications is a very fragmented market. They go into everything from pet trackers to smartwatches to very high precision timing devices that allow 6G and 5G operators to maintain one true time. Everyone looks to GPS or GNSS as a source of the right time. And if you think about a smart city, everyone needs to be on the exact same time. Otherwise, there's chaos and carnage potentially.
Right.
A couple of seconds or microseconds at a junction can cause catastrophe. So there's tremendous criticality in ensuring the synchronization of everything moving around the planet. And you
Yeah.
get that from GPS or GNSS. Now, what we do is let me talk a little bit first, if you don't mind, about Moore's Law. I think everybody's heard of Moore's Law in one way or another. And Moore's Law in semiconductor means that you shrink your transistors and you double the performance, and it's something that can occur every 2 years. This is the original version of Moore's Law. Now, in principle, what it means is that as you move electronics out of an analog type circuit into a digital circuit, you can follow Moore's Law, meaning you get more performance out of less transistors. And the physical space that those transistors take shrinks as you follow Moore's law. And more importantly, though, within the digital domain, those transistors, as they shrink, they get more power efficient and they get more performant. So you get these two effects as you shrink down in process nodes. We've taken about 90% of the analog circuitry in RF, radio frequency, and migrated it over to digital. We've digitized the RF receivers. And what that means is that our receiver technology can just follow Moore's law and therefore become more performant at lower power consumption levels and smaller size, and ultimately generate lower cost for the system and for our customers.
Okay, so you're really lifting the constraints that the analog systems were previously, limiting. So moving into the digital domain just has really changed the game, is what I'm hearing.
It is. We like to say that we're taking RF back in line with Moore's law, and most of our industry is facing a scaling wall, and there's a point of diminishing returns that just make it economically unviable for many of our competitors to continue to invest in integration of peripheral, complementary, or supplemental components in the system, and so on and so forth. So there are many different benefits to digital scaling that go well beyond the core technology itself.
Yeah. Now, you've described your advantage as structural and generational. What practical benefits does that create for customers in terms of power, size, performance, and cost?
And when we look downstream to our customers, we know that we can enable cycles of innovation for them. And that the source of that innovation is multifaceted insofar as, first and foremost, just the benefits from digital scaling allow them to free up more space on their motherboards or their subsystems. Imagine the typical wearables or smart glasses, for example. If you think about smart glasses, there's not a lot of real estate in that frame of a smart glass to fit high-performing electronics. And there's no way elegantly or aesthetically to dissipate the heat that comes from older generation technology, enabling the manufacturers of smart glasses with a highly integrated, digitally scalable and digitally performant device creates an cycle of innovation that we all benefit from. We're not going to be wearing glasses with stems that are an inch or two, that need to be an inch or two wide for functional reasons, maybe aesthetic, yeah, but not for functional. Or your wearable that you have on your wrist watch. With the space that you free up from using our technology, you can make a decision in terms of what to do with that space. You either make the form factor much smaller and neater and tidier, or you add more functionality to the empty space that we create by using our chip. That might be a sensor, an extra sensor, or an extra memory or extra compute power. Or you can put a larger battery. So not only are you consuming less power with your current battery from our technology, you're freeing up space so you can put a new battery, a larger battery in there. And now the battery life of your device is extended by 5, maybe even 10 times compared to what it was or compared to our competitors. And that's the wonderful thing about what we're building, is that you can see how it impacts the end user almost immediately. There's also a sustainability impact that makes a lot of our work really much more meaningful, because we can eliminate or we can extend the life cycle of devices just through battery life extension, and that has a net effect of pulling carbon out of the air.
So the downstream impact you're talking about for the user experience is not only extending the life of the products and wearables, you said, but the reducing space. And other than wearables, are there other products that you see this technology really impacting?
Yes, it's a very fragmented market. That's one of the characteristics of this market. Anybody that needs positioning, timing, or velocity or navigation information is ultimately a user of GNSS, and therefore our products or our competitors' products. And that ranges everything from, as I mentioned a while ago, pet trackers to smartwatches to last mile mobility to some of the very high precision timing requirements of backhaul for 5G or 6G cellular. or autonomous vehicles, autonomous agricultural vehicles. So anytime you can think of a device that needs positioning, velocity, or timing, you know that using some form of a chip like ours.
Okay. Now, Qualings is moving into volume production this year. What does this phase mean for the company, and what milestones matter most as you commercialize?
Yeah, we're fundamentally changing from a product development company to a product manufacturing company and a product sales company. And as a scale up, I mentioned a while ago about just staying one chapter ahead of the class or paving the road right in front of you. It's super, super critical as you make this transformation in the company because you have to hire an entirely different set of skills. You know, we're hiring quality management people, we're hiring commercial and supply chain people to service our customers and support our customers and our markets and our partners. So it's almost a personality change that the company will go through because we're bringing a very diverse set of skills in just to support the migration to manufacturing. Yeah, so it's an exciting time for the company. We just finished our Embedded World and Mobile World Congress exhibitions, and it's a very proud moment for the company to stand there and see that we have so many real products up and running on our booth in a place like Embedded World, surrounded by companies that are multi-billion-dollar market cap companies. And the visitors to our booth are asking, why can't they do what you do? You know, what's the difference? You know, and very, very exciting. So we're at that stage.
Yeah. Well, congratulations. That is very exciting.
Thank you.
Definitely.
Yeah.
With increased attention on positioning accuracy, anti-spoofing, and anti-jamming, how is the market evolving, and how does that change the urgency around what Qualings offers?
Urgency is the right word, and it is mission critical for any user nowadays to know that the positioning data that they have is authenticated and it's real, it's not spoofed. This used to be a problem that was limited to defense, aerospace and defense type applications. But we see from the news every day for the past year that spoofing is something that's impacting the civilian market and the commercial market as much as it is in the aerospace and defense market. Now, we've done several things to ensure that we bring authentication and resilience to our chip so that our customers know that they can rely on the quality and authenticity of the signal that they're receiving in our technology. Our partnership with the European Space Agency have a group called so the European Space Agency is responsible for building and launching the satellites for Galileo's constellation.
Okay.
The European Space Project Agency, USPA, is responsible for running the satellites once they're in orbit and providing the services. Now, that European constellation is called Galileo. There are about 34 satellites, and they provide services to 4 billion people on the planet.
Wow.
So every year, 4 billion people are connecting to the Galileo constellation. And what's unique about the European constellation is that they offer free services like authentication or emergency services, location to services, high precision services, in a way that the other constellations do not. Now, we partnered with the Space Agency about 3 years ago to fully embed their authentication service into the design of our chip. So rather than the service being software sitting on top of hardware, that software is deeply rooted into our silicon, because we were lucky to be designing our silicon at the same time as the service was launched. So we have that very unique advantage that it's fully optimized around authentication.
Right.
We have a few other parts of our secret sauce that adds up to a multi-dimensional, multifaceted architectural strategy that we have to improve resiliency and improve authenticity of the signals that our chips are receiving, because a single dimension is just not good enough. The spoofers can easily catch that.
Right.
And I'm happy to run through a few of them if it's interesting.
Yeah, sure.
Right, so classically, to avoid a spoofed signal, the users employ what's called frequency hopping. So you'll hop from a frequency to frequency, and you're hoping the spoofer won't catch up with you. Now, it's a sort of cat and mouse game. Now, we view that as a very singular dimension approach to ensuring authenticity. And it's not good enough, especially now with the sophistication of the spoofers. So we're introducing multidimensional capabilities to ensure that this game of cat and mouse is always in favor of us, the receiver chip, and the odds are stacked against the spoofer for finding your signal. And in addition to frequency hopping, we have orbital hopping. So we can hop from the GEO, which is the highest orbital satellites, to MEO, which is middle orbit, and then LEO, which is low Earth orbit. And LEO is where all the Starlink class satellites reside. MEO, middle Earth orbit, is where a lot of the traditional GNSS satellites reside. And then GEO is the furthest from the highest altitude. We can hop between each of these orbits to complement the frequency hopping. And furthermore, our chip and technology is fully reconfigurable dynamically over the air and on the fly. So you can create scenarios that enable the chip to hop between the bands, hop between specific satellites if you want, or hop between the constellations, or hop between ground-based station versus orbital satellites, and so on and so forth. So it's a multi-dimensional approach to beating the spoofers and just staying ahead of them.
Wow. And it's all integrated and built right into your technology. Like you said, you don't have to layer it. It's already embedded.
Exactly. Our off-the-shelf part comes with this capability. There's no premium, there's nothing exotic. You don't have to add any special external components to make it work. We're not relying on any AI or any algorithms to make decisions on behalf of the chip. One of the great fears that we have is the direction that some of the design philosophies are taking in the pursuit of low power, sacrificing the authenticity of the chip by implementing AI agents that decide what level of interconnectivity is necessary for a particular scenario. Without human intervention, an AI algorithm doesn't know what the contextual background is to these scenarios.
Right.
I can give you an example. If your bicycle gets stolen and you're in a city, well, a city is a very complicated area for a receiver to get authentic location data, because there's a phenomenon known as multipath, which means your satellite signal is bouncing off buildings, trees, cars, and everything before it gets to your device. So there's a lot of variance in the quality of the signal. And to eliminate that, you need to feed more power into the device, essentially, to ensure that it can clean up all the noise and get you nice, reliable signal. Now, if you're out in the countryside and you have open skies, you don't need that. You don't run into those issues. So if you stick a AI agent into the middle of your device and the agent says, well, in a complicated environment, I need to, consume a lot more power to have reliability of my signal. Therefore, I'll take all of these multi-bands, L1, L5s, multi-constellations, and deliver a very, very reliable signal to the user. Now I'm in open sky territory, no problem. I can shut down all of these high power consuming connections and focusing on the lowest power connection, and it's fine. But where's the context? Your bicycle was stolen and some guy is riding your bike out into the open countryside and you're never going to see it again. There's no context, right? So in that case of a theft of your asset, you don't want an AI agent deciding that that's a low risk environment, so we can just reduce the power and take the weakest signals.
True.
No.
Okay, got it.
The design philosophy has to be cognizant of the context.
Yeah.
And it's not worth shaving a few milliwatts off here and there and sacrificing safety and security.
Right. So, Tom, you mentioned partnerships, and partnerships seem essential in a fragmented semiconductor ecosystem. How do you think about building the right ecosystem relationships to accelerate adoption?
Yeah, again, a really insightful question, particularly in our industry. And it starts with the premise of there's no need to reinvent the wheel. We know what we're good at. We're really good at ultra low power GNSS receivers that are safe, secure, and always on, always connected. That's what we do. Then if you kind of abstract out of that, you know that you have all of these interdependencies in software and hardware and downstream and upstream. well, why would we want to solve for things like sensor fusion, or why would we want to solve for Galileo authentication?
Right.
Form a partnership. These are the experts. USPA is the expert on delivering authentication services from their constellation. Multiple vendors, such as InventSense, for example, for IMUs, for inertial motion units, 9-axis sensors, 6-axis sensors. We don't need to solve for those problems. We need to solve for the integration of those and make it seamless. And that's our philosophy.
Yeah. And as you look ahead, what excites you most about the future of precision positioning? And where do you see Qualings making its biggest impact over the next few years?
I think the biggest impact that we will make is to bring the highest grade of security in connectivity to every device. We won't discriminate between the very high end of the market versus what people would call the low end. It's not a low end. It's just a simpler use case, a pet tracker or your watch. We don't discriminate between those use cases. We can deliver the world's most advanced, secure connectivity in a power envelope that is typically only available to a entry-level consumer product. And I could put some numbers on that. When we're tracking and getting a position fix, a couple of position fixes every second, we consume about a milliwatt of power. And that's between 5 and, believe it or not, 20 times lower than some of our closest competitors. That's transformative.
Yeah.
And that's our entry point into the industry. As our competitors mature, that's our entry point. And we have all of this digital CMOS scaling ahead of us, so it can only get better and better. And that's what I think we bring to the not only now, but for the next 2 decades. I think we can continue to innovate and help drive these downstream innovation cycles that don't sacrifice performance for power or security for power. And we don't rely upon algorithms or AI agents to determine what levels of security or performance is right for every use case.
Yeah. Well, fascinating technology, very exciting times. And so, Tom, how can listeners learn more about you and about Qualings? How can they connect?
Well, Qualings is online, believe it or not, www.qualings.io. Or in L for Netherlands, but IO is better. And I'm on LinkedIn as well. So happy to connect, happy to engage. And we have a great team who are more than happy to engage with the ecosystem and connect and continue the discussion. I appreciate the opportunity, Leanne. Thank you.
Yeah, thank you. Yeah, Tom, thank you for joining me. And I'm looking forward to following your journey as you commercialize your product, and very exciting.
Great. Thanks so much.
And to everyone listening, thank you for tuning in to Industry Ignited. Be sure to subscribe and join us for the next episode. Until next time, stay bold, stay curious, and keep igniting industry.